Hello, this is Steeman and welcome to Genius Mathematics. In this video, we will be seeing about types of numbers. These are like the subcategories of numbers which will be helpful to differentiate some numbers. So let's start with odd and even numbers. So odd and even numbers are like opposite numbers. If a number is odd, it cannot be even. If a number is even, it cannot be odd. So the thing about odd numbers is it has to be written in the form of 2k plus 1. This is the thing with odd number. If a number is written in the form of 2k plus 1, where k is any integer, then that number is called odd number. If a number can be written in the form of 2k, where k belongs to integers, then that number is called an even number. Let's say we have example, let's say 7. 7 can be written as 2 times 3 plus 1. And 3 is an integer here, so 6 plus 1 7, this gives 7. So 7 can be written in the form of 2k plus 1. So 7 is an odd number. Some other examples are 13, 17, 101 like that. Now for even numbers, it has to be written in the form of 2k, because even numbers should be divisible by 2. That is another thing with even numbers. So let's say we have an example like 18. 18 we can be written as 2 times 9. That is 2 times something, 2 times an integer. So 18 is an even number since it can be written as 2 times something. So that is the thing with odd and even numbers. So the next numbers we have is prime and composite numbers. These numbers will be very helpful to finding whether a number is prime number or not. So let's start with prime number. Again, these and composite numbers are opposites of each other. So let's start with prime number. Prime number is something, a number that is not divisible by any other number except 1 and itself. That is, let's have an example. Let's take we have a number like 14. 14 is divisible by 1, 2, 7 and 14, which means this is not a prime number, because a prime number should be multiplied only with itself and 1, not any other numbers. So if we take number like 11, the divisors are 1 and 11. So it is multiplied by itself and it is 1, and it is multiplied by 1. So this is a prime number, and this is not a prime number because it is divisible by other numbers too. So this is the thing with prime numbers. The another interesting thing with prime numbers is 2 is the only even prime number, because it is divisible by 1 and 2 and that's it. But all the other even numbers are divisible by 1 itself and 2 and maybe some other numbers, but all the even numbers are multiples of 2, but only 2 is multiple of itself and 1. So this is another thing with even prime number. The only even prime number is 2. So that is the thing with prime numbers. Now the opposite of prime numbers, that is composite numbers. So composite numbers are the numbers that is multiple of itself, or that is divisible by itself, 1 and some other numbers, like we saw with 14. Let's take a different example for this. Let's say we have 27. It is divisible by 1, 27, 3 and 9. So these numbers are the divisors of 27. Here, if the divisors were only 27 and 1, then it will be a prime number. But in this case, it is divisible by other numbers too. So this number is a composite number. So then we will be seeing about 1. Is 1 a prime number or a composite number? The thing with 1 is, it is neither. It is neither a prime number nor a composite number, because 1 itself, because in this case, in the definition of prime or composite numbers, 1 and itself are the same here. It is divisible by 1 and itself, but both the numbers are same. So it cannot be said if it is a prime number or a composite number. Now the another number we'll see is 0. Is 0 a prime number or a composite number? So the thing with 0 is, you can say it is divisible by all the other numbers except 0. It is divisible by all the other numbers. So you will say it is a composite number. But 0 is also neither prime nor composite number. This is because the divisors of 0 is infinite. The factors of a number, if you want to say it is a composite number, it has to have finite divisors. As we saw earlier with 27, it had divisors of 1, 3, 9 and 27. That's it. So it has 4 divisors. But 0 has infinite divisors. So it cannot be said as a composite number. Again, it cannot be said as a prime number because it has divisors. So 0 is also neither prime number nor a composite number. So that's all with prime numbers and composite numbers. Now the next interesting category of numbers is, we have perfect numbers. This is like a special kind of numbers. So the thing with perfect numbers is, let's say, so the definition of perfect numbers is the sum of the divisors of a number except itself is the number itself. Now let's understand this definition with an example. Let's say we have a number like 4. The divisors of 4 are 1, 2 and 4. But we cannot include 4 in this definition because it says except itself. So take this 4 out. So the sum of the divisors of a number except itself. In this case, the divisors of 4 except 4 is 1 and 2. If we add 1 and 2, we get 3. It's the number itself, but 3 is not 4. So 4 is not a perfect number. Now the next example we will have is 6. The divisors of 6 are 1, 2, 3 and 6. Again, we cannot take 6 because it is in the definition. Because the definition says not to take the number itself. So if we add all these, 1 plus 2 plus 3, we will get 6. Since this number is same as this number, that is the number itself, 6 is a perfect number. So 6 is the first perfect number in the natural number system. The next perfect number in the system is 28. All the numbers between 6 to 28 are not perfect numbers. So 28, we will take 28. The divisors are 1, 2, 4, 7 and 14. If we add all these, 14 plus 7, 21, 21 plus 4, 25, 25 plus 2, 27, 27 plus 1, 28. So if we add all these numbers, we will get 28, which is the number itself. So 28 is a perfect number also. So this is the thing with perfect numbers. That is, if we add all the divisors except the numbers itself, then if we get the number itself, then the number is a perfect number. So the last thing we will see is co-prime numbers. We know what prime number is. We have seen it. But this is co-prime number. So we will take two numbers. Let's take 16 and 17. So co-prime numbers means these two numbers has to be divisible by a number other than 1. These two numbers are multiple by or divisible by 1, but that's not the important part here. Is there any other number that is divisible by both these numbers? No. So these two are co-prime numbers. There is no other number that divides both these numbers other than 1. So these are co-prime numbers. Let's take, we have example like 4 and 6. These two numbers has a common multiple, that is 2. Both these numbers are divisible by 2. So these two numbers are not co-prime numbers. The another way of telling if a number is co-prime number or not is the HCF or GCD, we can say both, is 1. If the HCF and GCD, they are both the same, the HCF or GCD of two numbers are 1, then they are co-prime numbers. In this case, the HCF is 2. So these are not co-prime numbers. But in 16 and 7, the HCF is 1. So these are co-prime numbers. So that's the thing with co-prime numbers. That's it. Thank you.